All right, so here's our first example for momentum. So we have a 0.7 kilogram ball moving horizontally at 5 meters per second, strikes a vertical wall, and rebounds with a speed of 2 meters per second. What is the magnitude of the change in its linear momentum? So there's a couple tricks here. Number one, if we're looking for change in linear momentum, right? So delta P. Now that is going to be change in mass times velocity. Usually when we're talking about momentum, when we have a change in momentum, it's because velocity is changing. So we can rewrite this as change in momentum is equal to mass times delta V. And then, of course, we know that change in velocity, or delta V, is final minus initial. So we end up getting delta P is equal to mass times the quantity final velocity minus initial velocity. So that's our first kind of thing that we need to do, is we have to actually find the equation that we need to use. Now, the next thing we want to talk about is our signs. So if this is my wall right here, I know that this ball is coming in at an initial velocity of positive 5 meters per second. Now, if it's rebounding at 2 meters per second, it's going in the opposite direction, which tells me that that's going to be a negative velocity, because if I said 5 is positive, that means that my final velocity, which is 2 meters per second, has to be negative because, again, it's in the opposite direction. So that's our initial and final velocity, and then we also know that the mass is 0.7 kilograms. So now we can plug in our numbers and we can find the magnitude of the change in its linear momentum. So we get change in linear momentum is equal to mass, which is 0.7 kilograms, times final velocity, which is 2 meters per second, minus initial velocity, which is positive 5 meters per second. So minus a positive 5. So we end up getting 0.7 times the quantity, negative 2 minus 5, and we end up getting a change in momentum of negative 4.9 kilograms times meters per second. Not sure if I mentioned this in the other video, but the unit for momentum is just kilograms times meters per second. It's not anything special. We don't have anything like, how force is newtons or something like that. There's no special unit for momentum. It's just kilograms times meters per second. Another thing to note here is that this change in momentum is negative. And that makes sense because if we have an initial positive momentum coming towards the wall, that change in momentum, the change is in the opposite direction. All right, so that's why we have a negative change in momentum.